Okay, so in the last video we talked about quantum numbers and what they are, and kind of the most reduced version of that explanation is it's kind of like the best guess of what a location of an electron would be. So each of these types of quantum numbers, no four of them can be the same for an electron. And we talked about the principal quantum number, N, the angular momentum quantum number, L, the magnetic quantum number, M sub L, and the spin quantum number, M sub S. So the question says, which of the following are permissible sets of quantum numbers? So with the exception of M sub S, the previous quantum number limits what that quantum number can be. So let's see which of these sets of quantum numbers are permissible for the rules of assigning quantum numbers. So we're looking at these four quantum numbers as A, these four as B, these four as C, these four as D. So let's look at A first. And let's see, are these four quantum numbers permissible for the rules of assigning quantum numbers for electrons? So remember, N can be any whole number integer. So yeah, that works. Remember, the rule for L is that it can be any integer from 0 to n minus 1. So that means this cannot work because it could be 0, 1, 2, or 3, but it cannot be 4 because the rule is L can be any integer 0 to n minus 1. M sub L, remember, can be anything from negative L to positive L, so that would be fine. And remember, M sub S is always plus 1/2 or minus 1/2, just telling the direction that the electron is spinning. So which of the following are permissible sets of quantum numbers? This is not an acceptable set of quantum numbers because L cannot be anything higher than 3 because the rules for L is that it can be 0 to n minus 1. So no, that is not a permissible set of quantum numbers. All right, so let's look at the next one. N is 3, L is 2, that's fine. If N is 3, that means L can be 0, 1, or 2, so that's fine. M sub L is 1, that's fine, because remember, M sub L can be anything negative L to positive L, so that works. And M sub S is negative 1. So all of these fits the rules. So this could be a possible set of quantum numbers for an electron. So let's look at C. It says N is 2, L is 0. That works because L can be 0 or 1. M sub L is 0. That works because it can be anything negative 0 to positive 0, so it has to be 0. M sub S is 3/2. Well, that does not work because M sub S has to be positive 1/2 or negative 1/2. So that's why M sub S is wrong. So these four, this is not an acceptable set of quantum numbers. So let's look at N, number D, letter D. N is 5, L is 3, M sub L is negative 3, and M sub S is positive 1/2. So all of these work. If N is 5, L can be 0, 1, 2, 3, 4. M sub L can be anything negative 4 to positive 4, and M sub S can be positive 1/2 or negative 1/2. So all of these work. So this is a permissible set. So you might see something similar like this on a SmartWorks problem or on an exam where you're given possible sets of quantum numbers and you would use the rules that we discussed in the previous video to see if those numbers were permissible or not.